In this session, we will start the discussion of the sampling distribution and the estimation theory. The distribution of all possible values that can be assumed by some statistic computed from the samples of the same size randomly drawn from the population is called the sampling distribution of that statistic. Therefore, in simply, if we define the sampling distribution, here we are going to, if we are having a population, then we are randomly drawn a sample from this population, and then for the sample that we have obtained, if we are calculating some statistics, and from this sample statistic, if we are identifying the distribution of the all possible values, then such technique is called as the sampling distribution of statistics. When we are going to discuss about the sampling distribution, there are some important terms, or we have to focus on the terminology related with the sampling distribution. Therefore, if I go through them one by one, the first is the parameters. The parameters are unknown constants. Parameters are said to be the unknown constants, and it indicates the population characteristics. Here what we are going to do is, here we are not going to think about any sample or any random sample obtained from population. Here, if we are interested regarding the population characteristic, then to denote these or to identify these population characteristics, we are using some unknown constants, and those are said to be the parameters. Generally, we are considering about the three parameters. In the next paragraph or these next points, we will discuss about these, what are the parameters that we are considering, the commonly considering parameters for a population. And in the previously also I told you that if you are having a population, in the previous sessions we have discussed, if we are having a population, what we are going to do is we are randomly obtain a sample from the population. Therefore, we are using appropriate statistical technique. What we are going to do is we are obtaining a sample from the population. Therefore, once we have obtained a sample, and if we have calculated the summary values for this obtained sample, or simply if we are saying that if we are obtaining the summary values for the obtained sample, then such values are said to be the statistics. For the population, if you are obtaining the parameters, or if you are summarizing the, or if you are identifying the population characteristics using unknown constants, those are said to be parameters. But if you are summarizing the values obtained from the sample information, then such are said to be the statistics. Statistical estimation. Then the next important term is the statistical estimation. Statistical estimation is the process of making a guess about the population parameters based on the sample information. It is quite like this. In the previous session, one of the previous session, I have explained this concept. What we are generally doing is, if we are having a population, since we cannot reach to each and every element of the population, generally we are obtaining a sample. Therefore, based on the sample data that we are obtaining, if we are going to inferencing regarding the population, then such process is said to be the statistical estimation. It is because based on the sample information, or based on the summary statistics that we are obtained from the sample, then we are going to make the guesses about the population parameters. Therefore, that process, so we simply say it as the inferencing technique. Therefore, that technique is said to be the statistical estimation. When we are estimating, then when we are estimating, in the sense we have to obtain the summary values. Therefore, if we are obtaining a value for a particular statistic, then that is called be a estimation. Therefore, estimation can be obtained either by the census or by sample method. If you are using the entire population for our survey, then it is said to be the census method. It is because we are considering each and every element inside the population. But if you are using a part of the population, then we can use it as the sample method. Therefore, by obtaining a sample, if you are making the estimations or if you are getting the estimations, then that is called as this sample method. Therefore, estimations can be obtained either by the census method, it is using the entire population, or else by the sample method, it is the random sample obtained from this population. Thereafter, we can have to pay the attention regarding the estimator. Estimator is supposed to be the statistic used to estimate a population parameter. It is a function of the, which is a function of the sample observation. Therefore, estimator is supposed to be a statistic which is used to be estimate population parameter. It is because generally we are based on the sample information, we are making the inferences. Therefore, the parameters that we are estimating based on the sample data, those are said to be the estimators, and it is always a function of the sample observations. It is because throughout the population we are obtaining the sample, based on the sample data again we are making inferencing about the population. Therefore, this estimator would be a function of the sample observation. And estimate is a particular value. Therefore, for estimator we are making estimations. Therefore, once you are estimating a value to an estimator, then such value or the particular value is said to be the estimate for the estimator that we are takes on the set of data. Therefore, these are the basic terms that we have to pay our attention regarding when we are dealing with the sampling distributions and the estimation theory. When we are moving for the process of the estimation, generally there are two types of estimation we are considering about. Simply we can say that there are two types of estimations we are considering. One is the point estimation. Therefore, if you are simply having the estimation, if we are having the estimation, then we can consider this as two categories. One is said to be the point estimation, and the next is supposed to be the interval estimation. Now you may understand about what is the point and the what is interval. It is because in the word itself it reflects what is the estimation that we are going to do. If we are obtaining a particular value or a single value for the population parameter using the estimation technique, such estimation is said to be a point estimation. Therefore, for a point estimation, we will have only one value. Therefore, simply we can say it is just a single value. If you are obtaining a single value for a population parameter, that is said to be a point estimation. But if you are moving for the point estimation, apart from or rather than using the point estimation, most of the time we would try to obtain the interval estimation. It is quite, if you are obtaining a value for a particular estimator as a point estimation, there may be some deviations from this point. Therefore, in the interval estimation, what we are going to do is we are going to find out what are the two numbers, what are these two numbers which this point estimator can be lies on. Therefore, when we are making the estimations, rather than or apart from obtaining the point estimations, we will prefer to obtain the interval estimations. It is because we can say that our estimator would be in one of these two values. It is quite as the region. Therefore, in between one of these two regions we can have the our estimated value. Therefore, this process is said to be this interval estimation. Always interval, in the word itself we can find out it is interval. In the interval, in the sense we have to always find out two numbers. Therefore, if you are taking two numbers, then the region between these two numbers is supposed to be the interval that the value can lies on. And when we are finding out the interval estimations, we generally focus on the parameters which are defined on the point estimation. Therefore, generally we are having three common parameters. Previously also I told that when we are discussing about these parameters, these are said to be the unknown constants which indicates the population characteristics. Therefore, when we are going to discuss and describe about the population characteristic, mainly we are using three parameters. Common parameters are population mean, population standard deviation, and the population proportion. These are the three common parameters which are used to discuss the characteristic of a population. Population mean is generally denoted by the notation mu, while the population standard deviation is denoted by sigma, and the population proportion is denoted by the uppercase letter P. But in the practical situations, what we all know is we cannot use the entire population for making the values. Therefore, in such situations, apart from using the uh, these population parameters, what we are going to do is we are going to find out the estimations for these uh, population parameter. Therefore, instead of using the population mean, what we can do is throughout this population we can obtain a sample. Therefore, using the sample data we can obtain the sample mean, which is denoted by x bar. Instead of using population standard deviation, we can just replace it by using the sample standard deviation, which is denoted by s. In the similar manner, for the population proportion, instead of using the entire population, based on the sample data, we can calculate the sample proportion P, or it is denoted as the lowercase letter p. Sometimes we can say it is, since it is the estimated value, it is denoted as the p hat as well. And when it is discussed about the sampling techniques, therefore in that situation we are saying that if you are having a large samples, using an appropriate sampling technique, once we are obtaining the parameters based on the sample data, those would be much more good estimates for the population parameters, which are said to be population mean, standard deviation, and the proportion. Therefore, instead of using mu, sigma, and uppercase letter P as the population parameters, we can simply replace them by using the sample mean x bar, sample standard deviation s, and the sample proportion, which is denoted by lowercase letter p. Therefore, we can say if we are having we are having the enough large samples, then these sample estimators would be good estimates for the population parameter. Therefore, hereafter what we are going to do is, instead of using these population parameters, we are inferencing on these parameters based on the sample estimations that we are obtaining from these three sample estimators, or sample, or the summary statistics. Now, I will directly move for the discussion on the interval estimation. It is because in the previous sessions, we have discussed about these point estimations, how to obtain the mean, median, or simply mean, this variance, proportion. Those things were previously discussed, and some summary statistics or the summary measures also discussed. When we are discussing about the summary measures for the central tendency, we have discussed summary measures for measure the variability. Then we have discussed the summary measures for describe the shape of a distribution. Those were discussed, but now what we are going to do is we are going to discuss about the interval estimations. Now we will move for the obtaining the interval estimations for the population parameters. When we are going to obtain the interval estimations for the population parameters, we are considering mainly them as the one sample case and two sample cases, two samples case. It is because if we are just having a single sample, and if you need to obtain the population, or if you need to obtain the interval estimations for the population parameter mu, sigma, and the population proportion, then we will use this technique. We will use the concepts we are discussed under one sample case, but some scenarios we may have to compare two samples. If you need to compare two samples, then we need to have the comparison between mu1 and mu2. If we are having two samples named as 1 and 2, then sometimes we may have to think about the two standard deviations, as well as sometimes we need to compare the two population proportions as well. Therefore, these are the two major areas that we are going to focus on. Therefore, we will consider about the one sample case first, and thereafter we will consider about the two samples cases thereafter. If we consider about the one sample case, here we are going to find out the interval estimations for the population mean, with the condition population variance is known. It is sigma squared is known. In here, what we are going to do is, here if you are having a population, and if you need to find out the estimation for mu, this estimated value can be said to be the mu hat. Then here what we are going to find out is the value for mu hat. What we have learned previously was, the estimator for mu hat would be equal to x bar. If we are finding out the estimator for population mu as x bar, this is supposed to be a point estimation. We are finding a particular value or a single value for the population mean. But apart from finding out the point estimation, obtaining point estimation, here what we are going to do is, we are trying to find out actually in which region this mu hat can be lies on. Therefore, we are finding out the lower bound for this mu hat and the upper bound for the mu hat. To find out the possible, all the possible values of mu hat, here we are considering another condition, that we know about the population variance. If you know the value for sigma squared, or if you know the value for sigma, if we know one of these sigma, if you know sigma, we can find out sigma squared, or in the other way around. Therefore, if you are having a known value for sigma squared, then we are trying to find out what is this 100 into 1 minus alpha percent confidence interval for population mean. Here, apart from obtaining a point estimation, I told you that here we are going to find out an interval estimation. Therefore, in the interval estimation, it is said to be the confidence interval where this population mean mu can be lies on. Then this confidence interval can be find out using the equation x bar plus or minus z alpha over 2 times sigma divided by root n, where x bar is the population mean, x bar is supposed to be the population mean, z alpha over 2 is supposed to be the critical value based on the standard normal distribution. Since we know the population variance, we can find out, we can use this concept. Therefore, since we can have the know about the population variance, we can find out, we can use this concept z alpha divided by 2 and sigma divided by root n. Therefore, if we know about the population variance, then we are generally assume that we are having a large sample. But here we are not going to especially mention about whether it is large or small. It is because we are having an idea regarding the population variance. Therefore, if we are having the large sample, or in the case of non-population variance, then we are using the we are using the standard normal distribution to obtain the critical value, and then this has to be the multiplied with sigma, which is said to be the standard deviation, and divided by root n, where n is supposed to be the number of observations in the data set. But apart from discussing this, I will first just have a quick look into this confidence region. If we are discussing about the confidence region, it is a technique quite like this. Here, suppose we are considering the point estimations. Generally, we are using, if it is a normal distribution, we can have the normal distribution in this way, a bell-shaped distribution. And in the previous sessions, we have known about, we had an idea regarding this normal distribution. This is a symmetric distribution. This is a symmetric distribution. Therefore, and it is symmetric around its mean value, symmetric distribution, and the symmetricity is around the mean value. Therefore, if you are finding out the distances away from this mean value mu, here we can find out the distances here, what we are defining as the empirical rule. Therefore, for the empirical rule, what we are considering was we are finding out the region of the region, the area of the region where this standard deviation units away from mean value mu. If you supposed to be this is the mean value we are having, and if you are considering one standard deviation unit away from mu, here if you are measure this distance as sigma, it is one standard deviation unit. Therefore, it is for the left hand side as well as for the right hand side. Then right hand side value would be mu plus sigma. Then this would be mu minus sigma. In this region, we are supposed to be, if you are considering the region from mu minus sigma, and if we are bounded it by the mu plus sigma, then this region contains at least 68% of the total data, or the probability that the value falls in this region would be equal to 0.68. Now, if you move another 1 sigma unit deviation away from this point, it means that if you have measure 1 sigma away from the point that we have defined previously, but if you are finding out the total distance deviated from the mean value mu, then this would be mu plus 2 sigma, and this would be mu minus 2 sigma. Then we can say that it is mu minus 2 sigma, and the next boundary is mu plus 2 times sigma. Therefore, in this region, we say that at least 95% of total data would be in this region. It is quite that the probability of falling a value in this region, there's 2 sigma units away from mu, would be 0.95. And if we are moving another 1 sigma unit away from this point, then here also another 1 sigma away from this point, then this can be considered as mu plus 3 sigma altogether. 3 sigma units deviated from mu value. Here also we can consider it as mu minus 3 sigma. Therefore, if you find out this region mu minus 3 sigma, mu minus 3 sigma, and mu plus 3 sigma, altogether we can find out that there is 99% of total data in between these 3 sigma units. Therefore, we can say that the probability of falling a data point in between these though the 3 standard deviation units away from mean value is 0.9, and therefore this is how we are using the empirical rule, and this would be helpful in finding out the critical values for finding out the interval estimations. Therefore, this is one point we have to focus on, and then the next point is finding out the 100 into 1 minus alpha percent confidence region. Here it is what we are supposing is going to identify is, if we are if I'm taking the normal distribution, so it is a symmetric distribution, then this is supposed to be the confidence interval we are having, and the region which is beyond the confidence limits. Here This is the confidence region or the confidence interval we are having, and the region beyond the confidence region or the confidence level is supposed to be the rejection region. Therefore, this would be a rejection region. And here also we can find out this would be also a rejection region. Therefore, we will discuss about this concept much more detailed manner once we are discussing about the hypothesis testing in the future sessions. Therefore, just have a quick idea regarding getting the value of alpha. I am quickly have a look regarding this as well. Therefore, the probability of falling into the rejection region, probability of falling into rejection region is falling to one of the rejection region is equal to alpha. Therefore, if we are considering about the probability, then this value would be alpha. Therefore, probability of not falling into rejection region is equals to then 1 minus alpha. Therefore, if you are saying this as a percentage value, that is why we are saying this is equal to 100 times 1 minus alpha percent, and this is supposed to be the 100 into 1 minus alpha percent confidence region. Therefore, this uncolored area is supposed to be the confidence region, and we are finding out the boundaries of this confidence region as the lower boundary for the confidence region and the upper bound for the confidence region. Therefore, this is the next thing we have to pay our attention more. Okay, now we will see about this one sample case again regarding the obtaining the estimation for the population mean once the population variance is known. If it is satisfying this condition, the known with the known population variance, we can simply use the equation x bar plus or minus z alpha over 2 times is sigma over root n, where x bar is supposed to be the sample mean. If you are taking this as the first case under the one sample, if you are taking the first case, it is the with the sigma squared known, uh, estimation for mu. It is once we are estimating mu, we can show it as the mu hat. Then for the estimation for mu hat can be obtained using x bar plus or minus z alpha divided by 2 times sigma over root n, where x bar is supposed to be the sample mean. Then z alpha divided by 2 is the critical value that we are considering. Here it is based on standard normal distribution. It is for this scenario sigma squared known. Then sigma is supposed to be the population standard deviation, and n is supposed to be the number of observations or number of data points considered for the data set. Now, using this equation, we can find out the upper bound and lower bound. Therefore, the upper bound and lower bound can be now shown for this estimated value for mu. It can be shown as x bar minus z alpha divided by 2 times sigma over root n, and up it is the lower bound, and upper bound would be x bar plus z alpha divided by 2 times sigma over root 10. Therefore, this is the estimated value that we can consider for the estimation for the population mean mu. Now we will focus on an example regarding obtain the interval estimation for the population mean when we are having a non-standard population standard deviation. Here, the example is taken as according to a survey conducted by a company using 50 employees, it was identified that the average salary paid by the company is $13,000, and it is known that the population standard deviation is $4,000. You are asked to construct the 95% confidence interval for the average salary of the employee. Here what we need to find out is we are need to find out the confidence region for average salary of an employee, and here we are asked to compute the 95% confidence region for the average salary of employee. In the sense we need to find out an estimation for mu. That's why it is denoted as mu hat. Then if we again go back to the information provided, they have done a survey using 50 employees. It means that there may be much more employees apart from that, but for the sample they had considered 50 employees, therefore value of n would be 50, and based on the sample data they have obtained that the average is 30. It is not the population mean, it is the sample mean. It is because that using the survey or the information obtained from the survey, they have found out that the average salary is $13,000. Therefore, here what we can consider is we are having in this example, the condition is sigma squared is known. It is because they have provided us the population standard deviation. Once we know the population standard deviation, we can simply find out the variance as well. Then if you note down the necessary values and the information provided, here what we know is we know that the value of n is supposed to be the observations considered for the survey. Therefore value of n would be equal to 50 since 50 observations were considered. Then according to the sample data, they have obtained the sample mean. It was 13,000, and population standard deviation was given, not the sigma squared. The sigma value is given, population standard deviation is given, therefore we can find out sigma is equal to 4,000. Now what we need to find out is we need to find out the interval estimation for mu hat. Therefore the next thing that they have provided us is when we are finding out the confidence interval, we are asked to find out the 95% confidence interval. 95% confidence interval in the sense, if you are having your distribution, we can consider that our normal distribution. It is quite like this, a bell-shaped distribution, but sorry for my drawings, bell-shaped distribution, and here we need to find out the confidence interval in the sense always we need to have uh, upper boundary as well as the lower boundary. Therefore, since it is 95% confidence, then what we know is 95% of data should be in this region. 95% in the sense 0 point, the probability of falling into this region is 0.95. Therefore, we can find out this colored area. Then if we are considered this area as A and B, the addition of A and B should be equal to 1 minus 0.95. Therefore, we can say that using that we can find out the alpha. Then based on that data, what we can consider is for the first part, what we know is alpha is equal to 0.05. Alpha can be now obtained using what we know is this is the confidence interval. Since it is 95% confidence interval, we know that the probability is equal to 0.95. 95% in the sense it is equal to 0.95. Then 1 minus this region is now equal to alpha. It is because if you again look back to the term 100 into 1 minus this alpha percent, in the sense this should be equal to 95%. Therefore, altogether what we are having is 100 times 1 minus alpha is equal to 95. Then what we can see is 1 minus alpha is equal to 0.95. In that sense, we can find out the value of alpha is equal to 0.05. Using this calculation, we can find out the value of alpha. Using this, we can find out the value of alpha. And thereafter, what we can do is, now we can apply the equation to calculate the value. Therefore, the estimation, or we can say that the 95% confidence interval for mu. Here we are finding out the estimation for mu, which is denoted as mu hat. Then 95% confidence for mu can be obtained as x bar plus or minus z alpha divided by 2 times sigma over root n. Now, if you find out or if you substitute the values, value of x bar was find out as it is 13,000. Then it is plus or minus z alpha divided by 2. Here we need to find out the value of z alpha divided by 2. The next thing I would like to highlight is, here we are considering not the alpha value, it is alpha divided by 2. It is because now we can find out that if this is region A and if this is region B, what we know is A plus B should be equal to alpha. But the next thing what we know is, A is equal, the region A is equal to region B. It is because we know that this is a symmetric distribution. Since this is a symmetric distribution, what we know is A and B should be equal values. Therefore, what we can consider is A is equal to, or it is 2 times A is equal to alpha. Therefore, in that scenario, we can say A is equal to alpha divided by 2. In the similar way, we can say B is equal to alpha divided by 2. Then one of this region can be defined as alpha over 2, and this would be alpha over 2, and this would be 1 minus alpha. Therefore, this is how we are defining the region. Now we can say this is equal to z. Value of alpha was 0.05 divided by 2. Then value of sigma, it is 4000. Then divide it by n in the sense value is 50. Now we know all the values apart from the value for z 0.05 over 2. If you furthermore solve this, we can find out it is 13,000 plus or minus. I will take this entire part for the calculation for the entire part at once. Now we need to find out the value of z. If you divide this by 2, we will get 0.025 multiplied with then 4000 divided by the square root of 50. Now we need to find out the value for z 0.025. If you again focus on the standard normal distribution, what we can find out is, if you are having the standard normal distribution in this way, then we can find out the rejection regions, or what we are saying as the levels of alpha. Then what we know is this red color areas would be the summation of this would be 0.05. Therefore, one of these should be equal to 0.025. Therefore, the area of this colored region, one of the area of the colored region would be equal to 0.025. This would be 0.025, and also here also we can find out this is also equal to 0.025. Now we need to find out the value at this point, and this is equal to be value of z alpha over 2. And if you find out the value here, this would be equal to minus z alpha divided by 2, since this is symmetric over the mean value 0. Since this is the standard normal distribution, we can find out that this value, the mean value, it should be definitely equal to 0. And the point which we get as this area 0.025 is, it is z alpha over 2. Here also we can say this value is equal to minus z alpha over 2. Now we need to find out the value for z 0.025. And here since it is given as the z, then we need to find out the, or we need to use the standard normal distribution. If you use the critical values for standard normal distribution, we may get this table. If I again briefly discuss about this table, what we know is this always gives the cumulative probabilities. This always gives the cumulative probabilities, which is given as, this always says that probability of x less than or equal to a particular value of x. Therefore, if you find out the values, if this is the x value, then it always gives the value. Okay, I will color this area. This always gives us the values for this colored area. It is the cumulative frequency. Therefore, this colored area is supposed to be the probability of x less than or equal to the particular value of x. Now what we know is if you consider about the area beyond this point, here what we need to find out is, we are now forgetting about this minus z alpha over 2. Just by thinking on this z alpha by 2, we need to find out this region. Now what we know is, if this the region is here, it is 0.025, this region is 0.025, and this uncolored region, oh I will take this uncolored region, this is equal to 0.95. Now what we need to do is, we need to identify this point. Therefore, if you consider the total area beyond this point, we can find out this according to our example, this area should be 0.95 plus 0.025. It is because what we need to identify is this point. Therefore, if you compute the area beyond this point, it should be addition of 0.95 and this 0.025. Here we are just considering about one side only to obtain the value, since we have divided the entire rejection region into two parts and only one part is considered for calculation. Then we can find out the entire probability is equal to 0.975. It is 975, and we always keep these probabilities with due up to 4 decimal places. And now we need to find out what is the value of x which gets this region as 9750. Therefore, first what we need to do is, we need to identify where this 9750 lies on, and we need to find out what is the relevant row and column which contains this 9750. If the value is not exact value or not the exactly appearing value, then we need to find out what is the most closer value for that. But here we can find out that 0.9750, we can now find out the value 9750. Therefore, we need to find out what is the row and column which contains 9750. It is 1.9, and the next decimal is 0.06. Therefore, we can find out the value at this point x is equal to, we can say this is equal to 1.9, and the second decimal first is 1.9, and then the next decimal is 6. That is how we are taking this value as 1.96. Therefore, if it is 95% confidence, we will always get this 9750, and using this technique, we can find out the value or the Z alpha divided by 2 is now equal to 1.96. Now we can substitute that in our equation. If you find out this value, now we have identified these values. It is uh, 13,000 plus or minus, and we are having this value as 4,000 divided by 50, and we need to find out the value which is for Z 0.025. Then we have identified this value is equal to 1.96. Now we need to find out the multiplication of these values. Therefore, I will do this calculation separately. Then I will have this as 13,000 plus or minus. If I do the calculation for this, then I am having this value as 1108, and I'm keeping it to two decimal places only, 74. Now what I can do is I can subtract this 1108.74 from 13,000. It would be my lower bound, and for the upper bound we have to add this value to 13,000. If you subtract the value, then we will get this value as 11,891.26, and the upper bound, once you add the quantity, then we will get this as 14,108.74. This is how we are getting the 95% confidence interval. Therefore, if you interpret this result, we can say that the 95% confidence interval for the average salary of an employee is $11,891.26, and say that it is 95% confidence interval. We can find out that this is in between 11,891.26, and the next value is 14,108.74. This is how we can interpret the result that we are obtaining from this. Now we will move for the discussion of the second part of this question. In the second part, they are asking what is the 90% confidence interval for the average salary of an employee. In the second part, what we need to do is they have provided the values are not different. It is because n, x bar, sigma, and sigma is similar, but we have to consider about the value of alpha. It should be a new value since we are asked to find the 90% confidence interval. Then what we can do is we can use the concept that we have discussed. What we are doing is we are finding out 100 into 1 minus alpha percent confidence interval. Here we need to find out 90%. Therefore, percentage signs will be cancelled out. Then 100 times 1 minus alpha would be equal to 90. Then 1 minus alpha, dividing both sides by 100, we will get this as 0.90. Then subjecting alpha, we will get this value as 0.10. Now what we know is value of alpha is 0.10. Then we can take the value of alpha divided by 2. It is simply divide this into two parts, then should be equal to 0.05. Now, the new thing that we need to find out to calculate 90% confidence interval for mu, we need to obtain x bar plus or minus z alpha over 2 sigma over root 10. We know the value of x bar, it was 13,000. Then z alpha over 2 should be now z 0.05. Then sigma was 4,000, similar as previous. Then new value is the value of n is 50. Now we need to find out the value of z alpha, z 0.05. If I draw this, then we can have this quite in this way. Now we need to find out the value. It is quite in this way. Now this region is this should be, here we are taking alpha divided by 2, then this should be 0.05, then this should be again 0.05, and this is the rejection regions that we are considering. And the next region that we need to consider, it is it is 90% in the sense 0.90. Now we need to find out what is the value here. This is taken as we said alpha over 2, and the minus value of that would be minus z alpha over 2. Here we are not going to obtain this value simply by replacing it with minus sign. Here we have found this value. Therefore, what we can do is now we can just calculate the entire area beyond this region is at alpha divided by 2. If you find out it using the normal table, still we are using Z table, it is because we are still having with the non-population variances. Therefore, now we need to obtain the new values for this. Now, the addition of these two values, it is here we had 0.90, and then the next value was 0.05. Altogether, this would be equal to 0.95. Therefore, I am keeping it to 4 decimal places since I need to find this value inside this set of values. Now, I am going to find out where is this 9500. Now we can see that here it is closer to 9495, as well as we are having the equal distance for 9505. Therefore, we can use one of these values. You can either use one the first set first value, or else you can use the next value. It is because you are having the equal distances away from 95004 both of these values. Therefore, um, sometimes we prefer to take the mean of these two values, but we are not going to go much deeper like that. Here I am simply taking the secondly mentioned value 9505. Therefore, we can find out this value is equal to the value of x. This is what we are taking as z alpha over 2, or simply we can say this is the value that we are taken as z 0.05. It is because here we are getting this point as 0.05. This value is equal to 1.65. But in some situations, if you are taking the lower value, this would be, if you are taking the lower value, this would be 1.64. If you are taking the mean value, we have to take the mean of these two. Then in some points, they are using this value as 1.645. But throughout this explanation series, I am taking this value as 1.65. Then we can have the substitutions for this. Then we can take this is equal to 13,000 plus or minus. Here it is 4,000 divided by root 50. And then we need to take the value z 0.05 or the value of z alpha over 2. It was identified as 1.65. Now what we need to do is we need to find out the appropriate values uh, for this answer based on the calculation what we have done. Then we can continue our calculation by considering the values separately. Here I am having the value as 13,000, then plus or minus. We have to obtain the answer for 1.65 multiplied with 4,000 divided by root 50. We are getting this value as 933 point. I'm taking it only up to two decimal places only. Then by subtracting this 933.38 from 13,000, we can take the lower bound as 12,066.62, and the upper bound of this value set can be considered as 13,933.38. Therefore, this is the 90% confidence region for the average salary. Therefore, we can comment on the result that we or interpret the result that we have obtained. Therefore, we can say that the 90% confidence interval for the mean salary or the average salary of the employees is it is 12,066.62 and it is 13,933.38 dollars. Therefore, this is how we can interpret the result that we are obtaining. Then in the third part, what we need to discuss is we are asked to find out the 99% confidence interval. 99%, first we need to find the value of alpha, then alpha over 2, and thereafter we need to find out the value of z alpha over 2 as well. Therefore, according to the notation and the definition, what we and the information, we can say this 100 into 1 minus alpha percent equals 99%. Then we can say it is 100 into 1 minus alpha, it is equal to 99. Then 1 minus alpha is equal to 0.99. In the sense alpha is equal to 0.01. Then dividing this into two regions, since we need to find the upper and lower bounds, then this would be equal to 0.005. Then we can find out the appropriate region and the value for z alpha over 2. Sorry for my drawings. Here we'll take this as just assume that this is a symmetric drawing and the symmetric distribution, and here this one region would be 0.005. This would be again 0.005, and this uncolored area would be 0.99 since it is 99% was considered, and we need to find out what is the value of Z alpha divided by 2. This is what we need to find out. Then we can take this value Z alpha over 2. Now what we need to do is we need to take we need to consider both of these. It is addition of 0.999 and 0.005. What we can consider here is I clear these drawings. What we had was it was 0.99 plus 0.005. In the sense we are having 0.9950. 0.9950 in the sense uncolored area was identified as 0.005. 9950, now we need to find out where is it. 9950, here it is 9950. We can take whether it is 2.57, it is this value. We need 9950. This is the value we need. Then here we can find out the both values have the same distance from 9950. Then I will take the upper level value. Therefore, the row and column associated with this, then we can find out the value is 2.58. Then this value is equal to 2.58. And if you take the lower value, we can take it as 2.57. Or else if you take the mean value, we can take it as 2.575. Since we have the similar distance for both points from the point 0.9950. But for the calculation, I will simply take the value as yeah, I will take the calculated value is 2.58. This is the value which I have calculated. Now we can find out 99% confidence interval for average salary. We can take this is equal to x bar plus or minus z alpha 2 over sigma over root 10. If you do substitution, it is 13,000. Then plus or minus z alpha over 2. Now we have found the value directly as 2.58. Then value of sigma was 4,000. Value of n was 50. If you perform the calculation, we will get this as 13,000 plus or minus. Then 2.58 multiplied with 4,000 divided by root 50. We will get this as 1,459.46. By adding and subtracting this quantity to 13,000, we may get the answer for the lower bound. It is equal to 11,540.54, and the upper bound would be 14,459.46. Therefore, same as previously, we can comment on this result as well. We can say that the 99% confidence interval for mean salary of employees is, now we can say it is $11,540.54, and it is $14,459.46. Therefore, this is how we can comment on the result that we have obtained. Now we will move for the next part. Here I have mentioned the solution as well. You can refer for them if you need them with the PDF. And now we will move for the next one. Here we are going to discuss about the interval estimation for the population mean when the population variance is unknown. In the previous case, what we had discussed was we have discussed about obtaining the interval estimation for the population mean when the population variance is known. But now what we are going to do is we are going to find out the value or the region set of values where that the sigma squared is unknown. But when we are considering about with the sigma squared unknown, here we are going to discuss this with two cases. If we are having sigma squared unknown, we are having two cases. The first one is large sample case, and the next one is the small sample case. For the large sample case, we are considering that the sample size is greater than or equal 30. For the small sample, we are considering the sample size less than 30. As the first case, we will consider about for a large sample, having the number of observation or the sample size greater than or equal 30. If even though we are having unknown population variance, but if it is still a large sample whether the number of observations are greater than or equal to 30, then still we can use the standard normal distribution as the distribution which follows the data set. Therefore, we have to find out the 100 into 1 minus alpha percent confidence interval for the population mean mu. We can use the equation, the previous equation, just by replacing the population standard deviation by the sample standard deviation. Therefore, the only difference with this equation with the previous one was, instead of using sigma, we have replaced it using the uh, sample standard deviation. Since population variance is unknown, we cannot use the sigma. Instead of sigma, we can use S, since S is a very good estimator for sigma. We have discussed it in the previously. Then using this equation, we can find out the 100 into 1 minus alpha percent confidence interval for the population mean mu. Here I will not going to repeat all the part A, B, and C. I will only discuss the first part, since the only difference in this calculation would be finding out the value of Z alpha over 2. I have discussed finding out the Z alpha over 2 in the previous calculation. Therefore, now I will explain the use of this equation only. Here, according to a survey conducted using 50 employees, it was identified that the average salary was paid by the company is 13,000, and using the same sample, they have identified the standard deviation was 4,000. But apart from using this what we can say, apart from using the sample standard deviation or using the population standard deviation, they have used the sample standard deviation. Since we can identify that it is somewhat a large sample, it is greater than 30, in the sense it is a large sample. Therefore, we can use this equation along with the standard normal distribution. In the first part, um, okay, prior to that, the sample standard deviation was obtained as $4,000, and it says that there was no information regarding the population variance. Even though, without knowing about the population variance, even though this term is not given, clause is not given, if it is simply stated that the sample standard deviation is provided, we can replace it using this, the population standard deviation can be replace using the sample standard deviation, and we can still use the standard normal distribution since it is a large sample case. Now we'll try to find out an answer for the part A. Here in this example, here it is a sigma squared unknown, but what we know is sigma squared unknown, but we are having the large sample case. We are having the large sample case. Okay, now according to the provided information, what we know is value of n, it was equal to 50. Based on the sample data, the mean was calculated as $13,000. Based on the sample data, value of S was identified as 4,000. and we need to find out this 95%. We said alpha over 2 along with this 95%, and they are asking us to find out the estimated value for mu hat. In the first part, they are asking us the 95% confidence region. Using that information 95%, we need to find out the value of alpha. Then we can take this as 100 times 1 minus alpha percent is equal to 95%. Percentage signs can be cancelled out. Then 100 times 1 minus alpha is 95. Then 1 minus alpha 0.95. Similarly, we can find out the value of alpha equals to 0.05. Then we can take alpha over 2 is 0.0. Here we will take this is what we are taking as 0.025, and we need to find out the value at this point. Here it is 0.025, and we can find out 0.025 in the sense here we can say this region is equal to 0.9750. Then using the similar manner that we have discussed previously, we can find out the value associated with this. We need to find out 2.50. It is value was 9750. 9750. We are having the exact value. Then we will take this value as it is 1.96. Then we will do the substitution. It is now equal to 1.96. Then we can take or we can do the substitution. 95% confidence interval for average salary or the mean salary. We can take the equation, it is x bar plus or minus z alpha over 2. Instead of sigma, now we are having the letter s. It is because population standard deviation has to be replaced with the sample standard deviation. Then x bar is needed to be considered. It is 13,000 plus or minus value is 1.96. Then value of S is provided as 4,000 divided by 50. Then this equation can be again solved as previous manner. 13,000 plus or minus 74. Then lower bound upper bound can be considered separately. Here we can take the lower bound, it is 11,891.26, and the upper bound is 14,108.74, and this is the 95% confidence interval, and you can comment it on the 95% confidence interval. We can say that the 95% confidence interval for the average salary is $11,891.26 and $14,108.74. Therefore, this is how we can comment on the result that we have obtained. The similar manner we can obtain the answers for part B and part C as well. It is 90 and 99%. The only difference is what we need to do is we need to have the new value for z alpha over 2. According to the value that we are getting alpha, we will get the critical value based on the standard normal distribution. And here also the solution is provided for your reference, and solution for part B and solution for part C also provided here. Now we will move for the next case. Here it is given as if what will happen if the sample size is small. In the previous, still we do not know or we do not have any information regarding the population standard deviation or the population variance. The only thing we know is we are having the data regarding the samples. Then what we can do is here the next thing is we are having a small sample. For the small sample, what we can, if you are going to identify the this 100 into 1 minus alpha percent confidence interval for the population mean, here we cannot use the normal distribution since we are having a small sample. To find out the critical value, instead of using normal distribution, here we tend to use the student t distribution. When we are discussing about the Z distribution or the normal distribution, we had just Z alpha over 2. But once you come to the T distribution, here we are considering T n minus 1 alpha over 2. Here this is what we have identified as the critical region. Critical region. And here n minus 1 is supposed to be the degrees of freedom, which is abbreviated as df. N minus 1 is the degree of freedom. Then we can consider about the 100 into 1 minus alpha percent confidence interval for population mean mu. It can be considered as x bar plus or minus t n minus 1, it is the degree of freedom, and alpha over 2 is the critical region, and it has to be multiplied with S over root n. Now we will see an example related to this, and I will explain how to get the Tn minus 1 alpha over 2 in this example. Using this example, I will explain how to get the critical value based on the T distribution. According to a survey conducted by a company using 12 employees, it was identified that the average salary paid by the company is 10,000. Then the sample standard deviation was obtained as $3,000, and there was no any evidence regarding the population standard deviation or population variance. Therefore, we are asked to construct the 95% confidence interval for the average salary of employee. First, we will try to find out, first we will note down what are the information provided for us. Here it is considered about the small sample case. It was given as n is equal to 12. According to the sample data, X bar was identified as 10,000, and the sample standard deviation S was calculated as 3,000. And here there is no any information regarding the population variance. We do not know, and we are asked to find out the 95%. I will take the first one. It is the 95% confidence interval. But what we know is here it is unknown. What we need to do is we need to find out the confidence interval for mean. Then it can be considered the equation as x bar plus or minus t n minus 1 alpha over 2. This times, instead of sigma, we do not know have any value for sigma, then s divided by root 10 has to be used. Then we need to find out this value using the t distribution. Apart from finding out this value directly, first we will try to get the value of alpha, the alpha divided by 2. Then what we know is it is 100 into 1 minus alpha percent is equal to 95%. Then percentage signs will be cancelled out. 100 into 1 minus alpha, 95. Dividing both sides by 95, we will get it as 0.95, where alpha is equal to 0.05. Based on this value, we can find out the value of alpha divided by 2. It is 0.025. Now we need to find out this value, and when we are going to find out the value, we need to take this value based on the t distribution. It is because we are having sigma unknown and small sample case. We are having a small sample. Since both these conditions are met, we have to find out this critical value based on the student t distribution. Now we need to take the value for t n minus 1 alpha by 2. We need to find out this value. The degree of freedom, it is n minus 1. We can take it is t n minus 1 in the sense 12 minus 1. It is equal to 11. Then alpha by 2, it is now equal to 0.02. We need to find out this value using the what we are considering as the student t distribution. Then we'll see how we can get this value. It is because we already know value of x bar, value of s, and value of n. Now what we can do is we can refer the student t distribution. Here we can find out this is the student t distribution. In the first column of this student t distribution, we are having the values for the degrees of freedom. Therefore, in the first column, we can find out the values for degree of freedom. And here, this gives us the information regarding the cumulative probabilities. And here it is one tail or two tail has mentioned. It is because the t distribution, the shape of t distribution, it is somewhat similar to this what we are considering as this normal distribution. Not exactly that, but it is also a somewhatly bell-shaped distribution. Then we can find out the values. Here what we can do is, if it is one tail in the sense, always we are considering either in the left side or the right side or the left side of these two tails if it is one tail. But if we are using this scenario with this concept once we are discussing the hypothesis testing. But when we are defining or when we are constructing when we are constructing the confidence interval, we always use the two tails. It is because always we need to find out the upper bound and the lower bound for the confidence region. Therefore, always we need to find out the two tails. Therefore, when we are considering about the two tails, we have to think about what is the addition or the summation of the area of these two tails. According to the problem provided, here it says that value of alpha is equal to 0.05. Therefore, if it is one tail, then it would be equal to 0.025. Then we have to read this value. If this is one tail, we need to find the value using this. But if it is two tail test, we need to predict the entire value alpha. Now we know the value of alpha is equal to 0.05. Then we need to find that value based on the two-tailed test. It is the 0.05. Now we need to find out the value from this critical region has to be obtained. Then we need to use this column. It is this column, and then we have already identified that degrees of freedom. degrees of freedom is equal to n minus 1, n minus in the sense it is 12 minus 1, when the degree of freedom, then we can say that the degree of freedom is equal to 11. Now we need to find out what is the crossing value of these two lines. If I draw them again, value is 11, and here it is like this, it is 2.201. In this manner we can find out the value of this critical value. It is now obtained as 2.201. Now we have to do the substitution in the equation that we have obtained, to which is used to find out the critical region, the confidence interval. Then we can say that the 95% confidence interval for the average salary, it is equal to x bar plus or minus. Here instead of this tn minus 1 alpha over 2, we can replace it as t11. We can directly write it as, okay, I will first write the notation. Alpha by 2 is used here, then s divided by root n. Now since I have used the value here, I will directly do the substitution. X bar is equal to, now it is 10,000. 10,000 plus or minus, critical value was identified as 2.201, and the value of S is obtained as 3,000, and value of N was obtained as 2. Then we can have the values, it is 10,000 plus or minus. We need to get the value for this multiplication. Then we'll get this as 1,906.13. Then we can perform the calculation. First we have to subtract this quantity from 10,000, 1,906.13. Then we can take this value as 8,093.87, and the upper bound can be obtained as the addition of these two values. It is 11,906.13. Then we can comment on the answer, the result that we have obtained. You can say that the 95% confidence interval for mean, here focus on here also about the mean salary. Mean salary, confidence for mean salary is 8,093.87 and 11,906.13. Therefore, this is how we are obtaining the value. And for the next two parts, it is part B and part C. Here it is asked to find out the 90 and 99% confidence intervals. Then the only difference is we need to find out the critical value, but all the other procedures will be same. Therefore, I will just discuss about obtaining the critical values. Here it is 90% confidence interval was considered. Then 100 into 1 minus alpha, 90%. Therefore we will have this 1 minus alpha, it is 0.90. Alpha would be equal to 0.10. Then alpha by 2 will be equal to 0.05. Now what we need to do is we need to obtain the critical value. It is n minus 1 alpha by 2. Then this is equal to, we had value of n is equal to 11. Then alpha divided by 2 was 0.05. Then first we need to find out whether we are having that value with this. We had for the alpha, what we had was now 0.01. If you are taking as alpha over 2, then it was 0.10, and here it is 0.05. Now we need to find out the value. It is if it is one tail, or if it is one tail, it should be zero point 0.5. If it is two tail, 10. Therefore now we can say, using the two tail, I am simply obtaining the value. Then we can take it is still with this 11. Then we can take the value is 1.796. What you have to do is, 11 was the degrees of freedom you had, and then we had the next value. It is what we are having as the value of alpha. Then the row and column which process, then we can get the value as the critical value. It is 1.796. Then we can say this is equal to 1.796. Then we have to do the substitution in the equation, x bar plus or minus. Then here it is the critical value 1.796, then multiplied with s over root 10 has to be considered. Do the substitution, and you can try for the answer using this concept. Then for the third one, we are following the same procedure. It is 99%. Then 1 minus alpha would be 0.99 and alpha would be 0.01, where this alpha by 2 is equal to 0.001. Here we need to find out the value of Tn minus 1 alpha by 2. Here also we are taking degrees of freedom as 11, since n is not changing. But if the value of n is changing, we have to pay our attention on that as well. Then alpha by 2, then it would be 0.005. Now we need to find out this value, whether it is provided in this table. Here we can see that value is there. Now what we are having is alpha is equal to 0.001, 0.01. Alpha by 2, it is 0.005. Now we can see that if it is two tail, value goes to 0.001. Then we need to match the row and column. Once you match the row and column, what we will get is here, if I clear and redo the calculation, here we can see value is 11. Value of n minus 1 is 11, and we can find out the column which contains 0.01 for two tails. It is alpha. Or if you simply need, you can use the one tail value as well. But for the easiness of calculation, I am always using the value of alpha. Therefore, we'll get this value as 3.106. Then this value is equal to 3.106, and again we need to do the substitution in the equation. 106 is s over root 10. Using this equation and using the appropriate substitution, you can have the values for these two questions as well, or these two parts of this question as well. And this is all what I need to discuss for this session, and thank you all for your participation.